The morning of April 18, 1942, broke cold and gray over the flight deck of the USS Hornet, somewhere in the vast emptiness of the North Pacific. Salt spray misted the air as 16 B-25 Mitchell bombers sat winged and waiting, their olive-drab fuselages glistening with ocean moisture. Lieutenant Colonel James Doolittle stood near the lead aircraft, his leather jacket buttoned against the wind, watching the horizon where Japan lay invisible beyond the curve of the Earth. In his cockpit, among the stripped-down instruments and extra fuel tanks, sat a standard-issue liquid-filled compass, unremarkable to American eyes, yet emblematic of an industrial philosophy that would soon shake the foundations of Japanese military confidence. The compass needle floated steady in its bath of mineral spirits, damped and precise, a small miracle of mass production that had rolled off assembly lines by the tens of thousands. No artisan had hand-fitted its jeweled pivot. No craftsman had individually calibrated its card. It was simply made, perfectly functional, and utterly expendable. In the cockpits of the Doolittle Raiders that morning, these compasses would guide aircraft through hostile skies toward targets that had never known the shadow of enemy bombers. But the true revelation awaited not in the raid itself, but in what would happen when one of these American instruments fell into Japanese hands. Across the Pacific, in the workshops and design bureaus of the Imperial Japanese Navy, compass manufacturing remained an art form inherited from generations of precision craftsmen. Each Type 97 aircraft compass required hours of meticulous assembly. Skilled technicians ground and polished the compass bowls by hand, ensuring perfect optical clarity. The magnetic needles underwent individual testing and adjustment, balanced to the finest tolerances by men whose fathers had performed the same delicate work. The liquid damping systems demanded careful mixing of alcohol solutions to precise viscosities, adjusted for the specific characteristics of each individual unit. Quality control inspectors examined every component under magnification, rejecting any piece that failed to meet exacting standards. A single compass might pass through a dozen pairs of skilled hands before installation in an aircraft. The Japanese took immense pride in this approach. Their compasses were beautiful objects, small masterpieces of the instrument maker's craft, as refined as the katana blades that symbolized the samurai spirit infusing their military culture. They believed such precision could only emerge from dedication, discipline, and the human touch of the master artisan. American methods, they assumed, must surely sacrifice quality for speed, producing crude instruments suitable perhaps for merchant vessels but inadequate for the demands of modern aerial combat. This assumption carried the weight of cultural conviction. For centuries, Japanese civilization had celebrated the perfection of craft, the sword-maker who folded steel 10,000 times, the potter who devoted a lifetime to mastering a single glaze, the calligrapher whose brushwork captured not merely characters but the essence of enlightened mind. The military had absorbed these values completely. Officers carried family swords passed down through generations. Pilots trained with an intensity bordering on the spiritual, seeking not merely competence but a transcendent unity with their aircraft. The Zero fighter itself embodied this philosophy. Light, nimble, requiring exceptional skill to fly properly, an extension of the pilot's will rather than a mere machine. Every component reflected careful thought and individual attention. The Americans, Japanese strategists believed, were a nation of mechanics and factory workers, capable of producing vast quantities of crude materials but lacking the refinement, the spirit, the sheer quality that Japanese craftsmanship ensured. The compass seemed to confirm this worldview. How could a nation that valued speed over perfection, quantity over quality, possibly produce navigation instruments worthy of serious military operations? The first captured American compasses reached Japanese technical intelligence units in the months following Pearl Harbor. Early American losses had been heavy. Aircraft downed over Wake Island, the Philippines, Java. Recovery teams pulled instruments from crashed Wildcats and Devastators, sending them to naval research facilities for analysis. The technicians approached these examinations expecting to document inferiority, to confirm what cultural certainty had already told them. They disassembled the American compasses with the same care they lavished on their own instruments, separating components, measuring tolerances, testing materials. What they discovered induced not satisfaction but a profound unease that rippled through technical reports with carefully neutral language concealing deep disquiet. The American compasses were not crude. They were not inferior. They were, in fact, extraordinarily sophisticated, but sophisticated in a manner that violated every principle Japanese industry held sacred. The liquid damping systems used a synthetic fluid that maintained consistent viscosity across enormous temperature ranges, from Arctic cold to tropical heat. Japanese compasses required different fluid mixtures for different operating environments, each painstakingly formulated. The American fluid worked everywhere, always, without adjustment. The compass cards showed no hand calibration marks, yet testing revealed accuracy matching or exceeding Japanese standards. The magnetic elements exhibited uniform properties impossible to achieve through individual selection and adjustment. Most disturbing of all, the manufacturing tolerances were loose by Japanese standards, yet the compasses functioned flawlessly. Parts were clearly interchangeable. Any American compass could be disassembled and reassembled using components from any other unit without loss of performance. This was intellectually offensive to technicians trained to believe that precision required individual fitting, that quality emerged from painstaking adjustment of each unique piece. How could instruments built to such apparently careless tolerances perform so reliably? How could mass production possibly achieve what Japanese craftsmen labored hours to perfect? The answer lay in systematic engineering that treated manufacturing as integral to design rather than as a separate process subordinate to craft tradition. American engineers had designed the compasses for production, calculating tolerances not to the tightest possible specifications but to the optimal point where performance met manufacturability. They had eliminated adjustment procedures by designing systems that functioned correctly within broad parameter ranges. They had substituted synthetic materials engineered for consistency in place of natural materials requiring selection and treatment. The jeweled bearings that Japanese craftsmen individually fitted and polished were replaced by standardized components produced by dedicated machinery to tolerances measured in 10,000ths of an inch, tighter than handwork could achieve but applied through mechanical consistency rather than artisan skill. The damping fluid emerged from chemical engineering laboratories where teams of scientists had optimized molecular properties for performance across conditions. The compass cards received their calibration not through individual adjustment but through statistical process control, ensuring that every unit met specifications without individual attention. The entire assembly could be completed by semi-skilled workers following clearly defined procedures, with quality assured through systematic testing of samples rather than inspection of every unit. Japanese technical officers studying these reports found themselves confronting an uncomfortable possibility. Perhaps American industrial methods were not crude simplifications of proper craft practice but rather a fundamentally different approach to manufacturing, one that achieved through systematic engineering what Japanese methods achieved through artisan skill. Perhaps the Americans had solved problems the Japanese were still laboring to address individually, and had done so in ways that permitted production at scales Japanese industry could not match. The compass represented not inferior workmanship but superior industrial philosophy, a philosophy that viewed the production process itself as worthy of the same intellectual rigor that Japanese culture reserved for the perfection of individual objects. This realization struck at the foundations of Japanese manufacturing confidence, suggesting that the contest between industrial systems might favor not the culture that produced the finest individual pieces but the culture that could produce good enough pieces in overwhelming numbers. The symbolic weight of the compass grew heavier as the war progressed and American material superiority became impossible to deny. In the skies over Guadalcanal, Japanese pilots encountered American aircraft in numbers that seemed to multiply despite losses. Each downed Wildcat or Dauntless appeared replaced by two more, then three, then dozens. The pilots understood intellectually that America possessed vast industrial capacity, but understanding and experiencing were different things. They had been told their qualitative edge would overcome American quantitative advantages. They had been assured that Japanese fighting spirit, Japanese training, Japanese aircraft design would prove superior to American materialism. Yet here were American planes everywhere, flown by pilots who might not match Japanese skill individually but who came in waves that Japanese numbers could not sustain. The compasses in those American aircraft became a tangible symbol of the industrial system producing such abundance. Each compass represented 10 hours not spent in hand-fitting components, 50 man-hours not dedicated to individual calibration, quality achieved through engineering rather than craft tradition. Multiply those saved hours across thousands of compasses, and the time liberated became available for producing more aircraft, more instruments, more of everything needed to wage industrial war. By 1943, Japanese aviators shot down over the Pacific and captured by American forces encountered a material world that further eroded confidence in their nation's industrial approach. The prison camps, despite being temporary structures, featured levels of standardization and logistical organization that astonished men accustomed to scarcity. Food arrived in canned goods produced by the millions, each tin identical to the next. Clothing came in standardized sizes that fit reasonably well without tailoring. Medical supplies arrived in abundant quantities, packaged with instructions so clear that even barely trained medics could administer effective treatment. Everything reflected the same industrial philosophy embodied in those compasses: design for production, standardization over customization, good enough in vast quantities rather than perfect in limited numbers. The captured pilots, many of them educated men from middle-class families, could not help comparing this abundance to conditions they knew existed back home, where rice rations had been shrinking, where military supplies arrived chronically short, where even basic necessities required careful husbandry. Some of these prisoners, in the long idle hours of captivity, discussed what they had seen and what it meant. The conversations were careful, coded, mindful of informers and the listening ears of guards, but the themes emerged clearly in post-war recollections and in intelligence reports compiled from interrogations. The American compass became a recurring reference point, a small thing, seemingly insignificant, yet representative of a vast gulf in industrial capacity and philosophy. One pilot, a former engineering student, reportedly explained to fellow prisoners how the Americans had achieved through systematic design what Japanese craftsmen struggled to perfect through skill. He described production lines where machines performed operations with inhuman consistency, where statistical methods replaced individual inspection, where engineering margins absorbed variation that Japanese methods eliminated through adjustment. He spoke not with admiration but with a kind of despairing recognition that Japan had entered a contest governed by rules that favored American strengths and penalized Japanese virtues. The craftsmanship that made each Japanese compass a small work of art was, in the context of industrial war, a luxury that consumed resources better devoted to producing adequate compasses in overwhelming numbers. The contrast extended beyond mere manufacturing to encompass entire philosophies of design and deployment. American aircraft instruments were designed with battlefield replacement in mind. A damaged compass could be swapped out in minutes by mechanics with basic training, using parts carried in standard supply containers. Japanese instruments, with their individually calibrated components and hand-fitted pieces, often required specialized technicians and careful adjustment even for simple replacements. American pilots carried survival kits packed with mass-produced items: compasses, mirrors, fishing line, water purification tablets, all standardized, all produced in quantities that permitted issuing them to every aviator. Japanese pilots carried personal items and perhaps a few essentials, but systematic survival equipment distributed to every pilot was a luxury Japanese logistics could not sustain. The American approach reflected an industrial system so productive that it could afford to equip every soldier with materials that might never be used, accepting waste as the price of ensuring preparedness. Japanese logistics operated on scarcity, requiring careful allocation of limited resources, unable to provision for contingencies that might not materialize. As American forces advanced across the Pacific, capturing islands and airfields, Japanese technical teams occasionally retrieved intact American aircraft and conducted detailed examinations. These studies revealed the same pattern evident in the compasses, instruments and equipment that sacrificed artisan refinement for producibility and reliability. The radio sets used standardized vacuum tubes interchangeable across multiple equipment types. The hydraulic systems employed synthetic fluids and standardized fittings. The electrical wiring followed color-coded standards that permitted rapid troubleshooting and repair. Everything spoke to an industrial culture that had systematized not merely production but maintenance, supply, and field operations. The Americans had created an integrated system where design, production, logistics, and maintenance formed a coordinated whole, each aspect reinforcing the others. Japanese industry retained vestiges of craft tradition that produced excellence in isolated areas but struggled to achieve the systematic integration that American methods enabled. The psychological impact of these discoveries permeated Japanese military culture in subtle ways. Pilots who had once taken fierce pride in their aircraft and equipment began to express quiet doubts in private letters and diaries. They still flew with dedication and courage. Japanese pilot quality remained high throughout the war, but confidence in ultimate victory eroded as the material disparity became undeniable. The compass became a dark joke among some units, a symbol of the enemy's incomprehensible ability to produce everything in endless quantities. "They have compasses for their compasses," one pilot reportedly wrote, "spare instruments for their spare instruments, and still they make more." The comment captured a fundamental truth. American logistics operated with redundancy unimaginable to Japanese forces. Supply lines carried not merely adequate materials but abundant surpluses, ensuring that shortages never constrained operations. Japanese forces, by contrast, operated on logistics so thin that a single disrupted supply run could cripple operations. The material culture embodied in something as simple as a compass reflected and reinforced these systemic differences. Back in Japan, industrial planners struggled with how to respond to intelligence reports detailing American manufacturing methods. Some advocated attempting to adopt American mass production techniques wholesale, retooling factories and retraining workers. Others argued for doubling down on Japanese craftsmanship, insisting that quality would ultimately prevail over quantity. The debates revealed deep cultural tensions between tradition and modernization, between pride in Japanese methods and recognition of their limitations in industrial warfare. The compass, in these discussions, became emblematic of the larger choice facing Japanese industry. Could they abandon craft traditions and embrace American-style mass production? Did they possess the machine tools, the raw materials, the electrical power, the trained engineers, and the management systems necessary to make such a transition? Even if technically feasible, could Japanese workers and culture adapt to assembly line methods that reduced craftsmen to machine tenders performing repetitive operations? The questions raised profound issues of national identity and cultural values, made urgent by military necessity but resistant to quick resolution. The reality was that Japan lacked the prerequisites for American-style mass production, even had the will existed to pursue it fully. The machine tool industry remained relatively underdeveloped, dependent on imports and unable to produce precision equipment in quantities needed to retool major sectors. Electrical power generation lagged far behind American capacity, limiting the viability of fully mechanized production lines. The scientific and engineering workforce, though talented, was smaller and less systematically trained than American counterparts. Management practices retained traditional hierarchies that hampered the kind of systematic process improvement American industry practiced routinely. Raw materials, especially oil and strategic metals, were chronically scarce, forcing conservation measures incompatible with the margins of waste that American mass production accepted as inevitable. Even had Japan possessed all these prerequisites, the time required to transform industrial culture would have measured in decades, not the months or years available during wartime. The compass represented not merely a different manufacturing approach but an entire industrial ecosystem that Japan could study but not quickly replicate. By 1944, as American forces approached the Japanese home islands, the material disparity had become crushing. American bombers filled the skies in formations of hundreds, each aircraft fitted with instruments mass-produced in quantities that Japanese industry could not hope to match. The B-29 Superfortress carried navigation equipment so sophisticated and abundant that backup systems had backup systems, ensuring mission completion even with battle damage. Japanese interceptors, magnificent aircraft in many respects, flew with instruments that represented the best Japanese craftsmen could produce, which was excellent by any absolute standard. Yet they flew alone or in small groups against American formations that seemed infinite. The symbolism of the compass had evolved from technical curiosity to bitter reminder of industrial reality. Those damped, liquid-filled American compasses, unremarkable and abundant, represented a production system that had outbuilt, outsupplied, and overwhelmed Japanese industry at every level. In the final months of the war, some Japanese technical officers prepared detailed reports on American manufacturing methods, intending these documents as foundations for post-war reconstruction. These reports analyzed the compass and other captured equipment with a thoroughness born of professional respect and painful recognition. They described American systematic engineering, statistical quality control, design for manufacture principles, and integrated logistics with the care of students examining the work of masters. The tone of these documents reflected neither defeat nor resentment, but rather a kind of clinical acknowledgement that Japan had confronted an industrial system more advanced in key respects than its own, and that learning from this system would be essential for future success. The compass appeared in these reports not as a symbol of American superiority, but as an example of engineering philosophy, a case study in how systematic design could achieve through mass production what craft tradition achieved through artisan skill, and how such methods scaled in ways craft traditions could not. The post-war period saw some of these lessons absorbed into Japanese industrial recovery. Engineers who had examined those American compasses went on to leadership roles in Japanese companies that would eventually become global manufacturing powerhouses. They brought with them hard-won understanding of systematic process engineering, statistical quality control, and design for manufacturability. The Japanese industrial phoenix that rose from wartime devastation synthesized traditional craft values with American production methods, creating hybrid approaches that combined the best of both philosophies. The compass, in this sense, taught a lesson that transcended military defeat, that excellence could be achieved through multiple paths, that craft and system both had roles, and that the most successful industrial cultures would be those that learned from competitors rather than dismissing their methods as inferior. For the American airmen who had flown with those mass-produced compasses, the instruments remained merely tools, functional and forgettable, replaced when damaged without sentiment or special care. The significance lay not in individual compasses but in the industrial system that produced them, a system that treated complexity as an engineering challenge to be solved systematically rather than a craft problem requiring artisan skill. This system emerged from specific historical and economic conditions: abundant resources, large domestic markets, high labor costs that incentivized mechanization, a culture of innovation and standardization, massive capital investment in machine tools and production equipment, and engineering education that emphasized systematic methods over craft traditions. The compass embodied all these factors in a single small instrument, making it a fitting symbol of American industrial power as it manifested in World War II. The Japanese pilots who examined captured American compasses and struggled to understand how such instruments could be produced in such quantities faced a revelation that cut deeper than military defeat. They confronted the possibility that their cultural certainties about quality, craft, and the superiority of artisan methods might be incomplete, that there existed alternative paths to excellence they had not seriously considered. The compass became, in this sense, a teacher, silent, inanimate, yet eloquent in what it revealed about industrial modernity and the multiple forms excellence could take. It suggested that the future belonged not to those who perfected traditional methods, but to those who could synthesize tradition with systematic innovation, craft values with production efficiency, artisan skill with engineering discipline. Decades after the war, veterans on both sides would occasionally discuss that conflict's material dimensions, and sometimes the conversation would turn to equipment and instruments. American veterans might mention the compass as they mention canteens or survival knives. Useful gear, nothing special, you grabbed what you needed and got on with the mission. Japanese veterans, when they spoke of the American compass, often did so with a different tone, conveying not mere respect for enemy equipment but a kind of philosophical recognition that they had encountered not just superior numbers but a superior industrial system, one whose advantages went deeper than mere productive capacity to encompass fundamental approaches to engineering, manufacturing, and logistics. The compass had astonished not through any single dramatic attribute but through what it represented, the integration of design, production, and deployment into a coherent system optimized for industrial warfare. In the end, the compass tells a story larger than navigation instruments, larger even than the Pacific War. It speaks to the transformation of warfare in the industrial age, when victory depended not merely on courage, training, and tactical skill but on the productive capacity to supply armies with adequate equipment in overwhelming quantities. It illuminates the tension between craft tradition and mass production, between excellence achieved through artisan dedication and excellence achieved through systematic engineering. It reveals how cultural values shape industrial practice, and how industrial practice in turn shapes military outcomes. The Japanese pilots who examined those American compasses with growing astonishment were witnessing not the superiority of one nation over another, but the collision of two fundamentally different industrial philosophies, and the harsh verdict that industrial warfare rendered on which philosophy served military needs more effectively. The liquid-filled American compass, floating steady in its bath of synthetic damping fluid, its mass-produced components fitted without hand adjustment, its interchangeable parts designed for replacement by semi-skilled mechanics in field conditions. This humble instrument encapsulated a revolution in manufacturing philosophy that helped determine the outcome of history's largest war. It represented the democratization of precision, the extension of quality from the workshop of the master craftsman to the factory floor where thousands of workers assembled millions of instruments to consistent standards. It embodied the American belief that excellence could be systematized, that quality could be engineered into processes rather than handcrafted into individual pieces, that abundance itself was a form of superiority worth pursuing. Against such philosophy, traditional craft values proved insufficient. The lesson was not that craftsmanship lacked worth, but that industrial war demanded production scales that craft methods could not achieve, and that victory would belong to the nation that learned to manufacture good enough products in numbers that overwhelmed any qualitative advantage competitors might possess. Somewhere in the vast Pacific, the descendants of those wartime compasses still guide aircraft and ships, their design refined but their fundamental philosophy unchanged. Instruments mass-produced to serve faithfully without requiring individual artisan attention, embodying still the industrial values that won a war and shaped a world. The Japanese pilots who first encountered these instruments with astonishment have long since passed, but the questions they grappled with remain vital wherever traditional craft confronts systematic production, wherever quality through individual attention competes with quality through engineered consistency, wherever the values of artisan culture meet the demands of industrial scale. The compass offered no simple answers, only the enduring reminder that excellence takes multiple forms, that different industrial philosophies serve different purposes, and that the greatest industrial cultures are those wise enough to learn from competitors, humble enough to acknowledge when alternative approaches prove superior, and flexible enough to adapt their methods while preserving their values. In this sense, the compass became not a symbol of one nation's superiority but a teacher of industrial wisdom, its lessons as relevant today as when Japanese pilots first examined American instruments and discovered that mass production had achieved what they believed only craft tradition could accomplish: precision, reliability, and quality, rendered infinite through the alchemy of systematic engineering.